Alright, ladies and gentlemen, it's time for us to talk about the electron. So we've looked at how electrons jump up, excited state, ground state, how that produces light and color. We've looked at Bohr models of atoms and how we can draw where those electrons are found relative to the nucleus. But we've never really talked about what the electrons do around the nucleus. I've mentioned several times in class that they don't actually orbit around the nucleus, so the idea of them spinning around in circles around that nuclear sun, it doesn't exist. But now we're going to talk about what they're actually doing. So a lot of this is going to be definitions, maybe sketch a couple pictures, but it's a lot of things just to write down and then remember. So make sure you note any questions in your notebook, that when we come to class we can start asking those questions and start really grasping what's going on with those electrons. Okay, so electrons are actually a lot like you, in that they have a place where they live, where they reside. So we know that electrons reside outside the nucleus, in a region that we've hereto called the electron cloud. But saying that electrons live or reside in the electron cloud is like saying you reside on Earth. It really doesn't describe much. It's a very, very big region. We need a better definition or a better way to pinpoint the location of an electron, just like we need a better way to define where you live. So if someone asked you where you lived, as long as they weren't a complete stranger, you probably would tell them something other than just Earth. You would describe basically 4 ways to define where you live. First off, you would tell them the state that you live in. Okay, well, I live in Oregon. That's still very broad. You know, Oregon is a huge state, and so you could be anywhere within the state. So let's narrow it down a little bit farther. Next, you would tell them what city you live in. And so, I live in Dallas. Well, that narrows it down a little bit. So I live in the state of Oregon. I live in the city of Dallas. If we wanted to find that a little bit more, we could tell them our street. Okay, so I live in the state of Oregon, the city of Dallas, and on Holman Street. So that right there, that's 3 ways, and we've really narrowed down where I reside. But we need to pinpoint it even farther, and if we wanted to do that, we would finally give them our street number. So with those 4 pieces of information, we can pinpoint exactly where a person resides. You give them the state, the city, the street, and the street number. Once we know that, we know where a person lives. We can do the same thing with an electron. Electron has 4 particular numbers or 4 particular things that we use to pinpoint its location. So the 4 ways that we define an electron's location are the principal number, the sublevel, the orbital, and the spin. And these are just like these guys down here. So the principal number is very, very broad, so it's like a state. The sublevel narrows it down a little bit, it's like the city. The orbital is like the street, and the spin is like the street number. So as we move down this, all 4 of them are used to describe the exact location of an electron. Any of you guys who are science fiction fans or seen any kind of science fiction movies, you've heard the word quantum before. These 4 things right here are defined as quantum numbers. And quantum numbers are what we use to define the location of an electron. Alright, so the first one we're going to talk about then is the principal quantum number. This is actually one that we are already familiar with. The principal quantum number is just the one that tells us how far the electron is from the nucleus, and it's just what we've drawn before as the energy levels. And so an electron that has a principal quantum number of 1 is in the first energy level. If it has a principal quantum number of 2, the second, third, 4th, 5th, 6th, it keeps going on. So the principal quantum number is also known as the energy level, and that's the term that we've used before. And what the principal quantum number indicates is the distance of the electron from the nucleus. So an electron in the first energy level is closer to the nucleus than an electron in the third energy level. And so just like a state, kind of describes where in the world you are, the principal quantum number describes where in the electron cloud it is with respect to the nucleus. But it's still fairly broad, because if we talk about, the third energy level, well, that's a pretty big region. Then where in that region is the electron? So we need to go a little bit farther, and that's where the second quantum number comes from. Before we look at the second quantum number, something important to note about this is it's just marking a distance. That just indicates a radius. So something in the second energy level is that far from the nucleus. It is not a circle. Electrons do not occupy circles. They just mark a distance with the energy levels. Okay, repeat that in your mind several times. Write it down there so you do not forget. Electrons do not occupy circular energy levels. They just mark a distance. That being said, let's talk about the second one, called the sublevel. So within each energy level, okay, so the main level, there is sublevels. So levels within the level. And those levels are where the shapes come into play. So the sublevel indicates the shape of the region that the electron is in. And there is 4 possible shapes within the quantum world, within the electron world. And so these shapes kind of just mark an area where the electron roams around. The first shape is referred to as S. And the S shape is spherical. So it's a 3-dimensional sphere, S spherical. The next shape is P. And P has a dumbbell shape. So think of it kind of like 2 S regions next to each other. The next shape is the D. And the D has kind of a 2 dumbbell shape to it. So 2 dumbbells running in different directions at the same time. And then the last shape is F. So S, P, D, and F. And the F shape, well, there's actually several different F shapes, so we won't bother to draw any of them. They get really complex at that point. They don't make anything familiar to us. And so just like in America, there's 50 different states, in the sublevel world, there's 4 different sublevels. So within each region, or within each energy level, you can have different sublevels. So if we look again at our little Bohr model, we see our different energy levels that mark a distance from the nucleus. Now, as we go out, what you're going to notice is that the region gets bigger and bigger. So if you look at n equals 1, that's a pretty small area. But if you look at n equals 3, that's a much bigger area. And n equals 4, even larger of an area. So what that means is as we go out from the nucleus, we can hold more shapes. So in the energy level, n equals 1, so that's the first energy level, you can only fit one shape, and that is the S shape. So within this region right here, we can only fit the S shape. If we go out another row, and so now we're here at n equals 2, it gets a little bit larger, so that means it can hold another one. So in the n equals 2 energy level, you could have the S or the P shape. And this S is different than this S. This is the 1S, this is the 2S. So in the first energy level, just the S. In the second energy level, S and P. And then with the third energy level, can anyone guess what's going to be there? Yeah, you got it. The S, the P, and the D. And this S is different than that S and that S. This is the 3S, the 3P, and the 3D. So these are not the same P's. They're just different regions because they're farther out. So this P is farther from the nucleus than this P. This S is the farthest from the nucleus. That one's the closest to the nucleus. And then the n equals 4, so the fourth energy level. What do you imagine is going to be there? The S, the P, the D, and the F. So now when we talk about an electron, we can tell you what energy level it's going to be in. So if it's in the third energy level, let's say, then we can talk about what shape it's going to be in. Is it going to be in the S, the P, or the D? So an electron might be in the second energy level, in the P sublevel. But that's not quite good enough. That's like telling someone what city you live in. We've got to narrow it down farther. So to narrow down the sublevel, we're going to talk about the orbital. So this would be kind of the sublevel of the sublevel. And what this indicates for us is kind of the direction of the sublevel. And that would be in like 3 dimensions. So when we draw pictures like the P's, we drew the P as kind of a dumbbell shape-ish. Okay, that's flat though, that's 2 dimensions. We could also draw the P sublevel as up and down, so if this is the x-axis, this one's the y-axis, or we could have it on the z-axis, which means that it's coming in and out of the page instead. So really, and that's true, there's 3 different forms of the P sublevel. They're called the P orbitals, and they're the direction of the sublevel. And once again, there's 4 different sublevels, and then each sublevel has a set number of orbitals, and it kind of depends on how big it is. So the S sublevel is fairly small, and so it only has 1 possible orbital. So there's only 1 version of the S. The P is a little bit bigger, and it has 3 possible sublevels. The D, even larger, has 5, and the F has 7. And so what this tells us then is any S sublevel, be it the 1s, the 2s, the 3, the 6s, would only have 1 possible orbital. So there's really only 1 street in S-town, if you will. As opposed to the D, if it's the 3D, the 4D, the 5D, it's going to have 5 different sublevels, so 5 different versions of the D. The F has 7 different versions, the P has 3 different versions. And something of very, very high importance. So write this down, circle it, highlight it, write it in a different color, something to where it'll catch your eye, and you can remember that the sublevel, each sublevel can hold 2 electrons and 2 electrons only. So each orbital can only hold 2 electrons. That's its maximum capacity. That means in the S, there's only 1 orbital, which means the S itself can only hold 2. The P sublevel has 3 different orbitals, and each orbital can hold 2 electrons. And so if it has itself 3 different P's, and each one can hold 2 electrons, that means the maximum capacity of the P is going to be 6. So P can hold a total of 6 electrons, 2 in each. The D sublevel has 5 different orbitals, and each one can hold 2 electrons. That means the maximum capacity of the D is what? 10. And then the maximum capacity of the F, if there is 7 sublevels within the F and each one can hold 2, that means the maximum capacity of the F is 14. Alright, we're getting close to the end. What we have now done is we have isolated the different energy levels, so 1, 2, 3, 4, and 5. We've said within the different energy levels, there's different possible shapes. They are the S, the P, the D, and the F. And then within each of those shapes, within each of those energy levels, there is different sublevels or orbitals that can hold 2 electrons each. So what we've done is we have narrowed it down to the space with only 2 electrons. Like if this one right here, let's say this is the 3rd energy level, the D sublevel, this particular orbital, and it has 2 electrons. We need a way to distinguish between those 2 electrons, and that brings us to the 4th quantum number. So if we think of 2 electrons that are in, we'll say, the 2nd energy level, the P sublevel, we've got 2 electrons there. Remember, electrons have similar charges. They're both negative, and so if they're both in an area together, they're going to try and repel each other. And that's because like charges repel each other. So we've got those 2 electrons trying to occupy the same area. How is it that they can coincide? And the answer is by spinning opposite directions. And this is kind of a relative term that scientists have given it, and really it just means that the electrons are going to have a slightly different charge because they're going to be spinning opposite directions. So let's say that electron right there, it's spinning in, we'll call that a counterclockwise direction. Well, then the other electron is going to be spinning in a counterclockwise direction, and that will give them both kind of separate or different charges so that they can occupy the same area, so that they can be close to each other if they have to. So the take-home message then from the spin is if we have 2 electrons per orbital, we've narrowed it down that far, they're going to have opposite spins. So they're going to be spinning opposite directions. And the value we give to those spins are either positive 1/2 or negative 1/2. And it's arbitrary which is which. We just know that they have opposite spins, so one's going to be positive half, one will be negative half. And that brings us up to date. So you might need to watch this video a couple times, ask some questions in class. We're going to practice with this. We're going to learn a couple different ways to notate this, so to talk about exactly where electrons are in a particular atom, in a particular element.